Hello, my name is Ifigenia Keramitsoglu, and I'm a research director in Earth observation at the National Observatory of Athens in Greece. What I will be talking about today is a project called HEATWISE that is funded by the European Space Agency, ESA, about the next generation urban heat products from future ESA missions, shaped through a stakeholder consultation. So here, this presentation is not going to be so technical, but the aim is to show you the process that we have adopted in order to take into consideration the requirements of stakeholders and how these requirements shaped the future products for the urban environment and heat. A few words about the project, the HEATWISE project. HEATWISE stands for High Resolution Enhanced Analysis Tool for Urban Hyperspectral and Infrared Satellite Evaluation. And the goal is the identification and characterization of buildings and roofs, vegetation and water surfaces. So this red, green, and blue, you will be seeing it a lot in this presentation. So we want to develop and validate 3 new urban products exploiting data from the upcoming Copernicus expansion missions called CHIME and LSTM. So the products are A, maps of urban materials, and to be honest, this is the one I will be talking mostly today. B is the advanced local climate zone maps, and C is the urban water characterization. The idea was to deliver representative data sets of the Copernicus expansion missions to simulate an operational scenario suitable for these selected applications, and then to actually develop these 3 products and share, what it will look like. Regarding the maps of urban materials, we know that in different parts of the spectrum, like in the visible, in the near infrared, in the shortwave infrared, in the thermal infrared, these all regions of the electromagnetic spectrum can provide detailed insights into the specific materials contributing to the urban heat island phenomenon and mapping the hottest areas with unparalleled detail. We have comprehensive maps of the various materials that are present in these hotspots of the city, and the products are going to focus on the thermal properties such as the emissivity and the thermal inertia. Regarding the local climate zone maps, this local climate zone describes a classification system that integrates various information about the height and the density of an urban area. And this is going to, this is a standardized somehow observation. We're going to use it within the context of HEATWISE, and we're going to actually advance it by integrating hyperspectral, visible and shortwave infrared and multispectral thermal infrared observations from the 2 new missions, CHIME and LSTM. And this will add further layers of information, which are so far not being used when we characterize the local climate zones. And the third is the urban water characterization, because these provide like cool places in a city. So we're talking about urban water bodies, but also in coastal areas, in coastal cities, what is happening in the nearby water areas. This is enhancing the ecological and aesthetic value of cities, impacting the microclimate, and of course these have to be taken into consideration. What we want to add here is the map and characterization of the biogeochemical and physical status from visible near infrared and thermal infrared data. Now moving to the stakeholder engagement. This project is under the umbrella of the Sentinel User Preparation Project. This is a flagship project of the European Space Agency. And here we have 3 cities where we are going to develop and validate our products. One is Athens, and I will be talking mostly about Athens in my presentation. That is a Southern Europe case affected by heat waves, by extreme heat, and we have the involvement of new Metropolitan Attica, but also we got information from other stakeholders. I will explain how. Berlin as a Central Europe case and Helsinki as a Northern Europe case. We have a structured approach for stakeholder engagement, leveraging what we call the city contact points as the main facilitators for the user input. We have built questions that could serve as a flexible framework for discussions, and this was designed in collaboration with, at least for Athens, with Carmine project, and this is a photo that you see of us there, where we had the specific session during the Carmine Living Lab in Athens. We have a living lab that is dedicated to heat, and in the first workshop we actually had a session dedicated to HEATWISE where we gave these guiding questions, and we had a very useful discussion with stakeholders. These guiding questions had to do with the usefulness of such products like the ones that I described before about materials, about local climate zones and urban water, about data analysis requirements, about the integration with existing work procedures, because this is a key element for the uptake, the further uptake of these future products by the stakeholders. And also we asked about the area prioritization that would be very important for the stakeholders that participated in the meeting. So the question was like, can this, which geographical areas or urban zones should be prioritized based on risk, vulnerability, or strategic importance. It is interesting, actually, what they provided. Then we collected these answers from the guiding questions, and we had on the left the spatial, temporal, the usage, and the format, and we mapped them. Here you see the mapping for the materials product to stakeholder needs, and from this to product requirements, and from this to representative data requirements. So I'm just going to go through only the first one. So for the spatial questions, we collected the stakeholder needs. They were talking about neighborhood and building block scale data. So this translated to a requirement for the product that should have a spatial resolution equal or better than 100 meters, with a target being 50 meters. And then, so for the representative data requirements, this translated to 50 meters for the thermal infrared and 30 meters from the visible and shortwave infrared data. Same goes for the other ones. I'm not going to go into detail, but I wanted to show you how from the questions you go to the representative data requirements. Similarly, we did for the local climate zone product and the water products. But I want to say a few more things about the project synergy, because I think that this was a very successful case where 2 projects collaborated. So we have on one side, we have Carmine. Carmine is a Horizon Europe project running for 4 years. Athens is a common case study area for Carmine and HEATWISE. And then we have ESA-funded HEATWISE. So you see, we even have projects from different frameworks, but we managed to make them collaborate successfully. So let me go through this visual on the right, to say that we started with Carmine, CSA area of Athens. CSA means case study area of Athens, living lab, and the geodesign process, where we had the dedicated HEATWISE session, as I said before, and the questionnaire, and we identified priority areas, which was in this case Sepolia. Sepolia is a part of Athens, a neighborhood of Athens, an area that has quite high temperatures. So we took this into consideration into HEATWISE. The questionnaire framed the technical specifications, as I showed in the previous example, and also we had a pilot that was specific for Sepolia. It was targeted to Sepolia, that was identified by the other project as a priority area. Then during the Carmine General Assembly in Brasov, that was in March 2026, we disseminated the information and the products that we have created, which I'm going to present to you in a few minutes, to the whole consortium of Carmine. We got feedback, and we had answers to a very short survey. Also, we will ask you to give us your feedback in this survey. And now, after the Brasov meeting, we are going to have a dedicated online session where we present the results to the Living Lab participants. So we go back to the group that helped us formulate and frame the technical specifications, and we're going to present the results and get feedback on the products. This will be a more detailed presentation than the one that you're seeing today. And these valuable partners are going to receive a HEATWISE Acknowledged Contributor stamp to thank them for their participation. And then HEATWISE is going to iterate. So what we have done for Athens, we have utilized data that was acquired during an ESA campaign in Athens some years back. The campaign was called Thermopolis. And we used this data in order to produce the synthetic CHIME and LSTM datasets. Because you see, when you're working for a future mission, the first step and quite critical one is that you don't have the data that you will apply your algorithms to. So you have to make them in a synthetic way. And this is what we did in HEATWISE. So we used the airborne datasets and also spaceborne datasets from other satellites, existing satellites. We also used some auxiliary data, and with proper modeling, we have produced the synthetic CHIME and LSTM, and these were used for our algorithm development. If you are interested in this part of the project, then I suggest that you see our recent publication for simulating and validating CHIME and LSTM data for urban material characterization, that is published in Remote Sensing Journal. And the link is on top. Now I'm going to the portfolio of the innovative products. Firstly, we have the material abundances. This is the Sepolia case study area in Athens that I mentioned before. It was actually identified as a sensitive area from Carmine project, and after being identified as a sensitive, vulnerable area and candidate for hotspot interventions, we proceeded with the analysis of the materials for this area. Here you see the abundance from 0 to 1 from 4 different materials: asphalt, concrete, vegetation, and metal. And here you see the different maps. But what we did is that we took the abundances a step further, and we found the percentage, the abundance of these materials in industrial and commercial blocks. So it was important to see in these blocks what was the percentage of the different materials. So instead of having just a raster, then we converted this to something that we think is far more useful for the stakeholders, that is to work with building blocks and characterize the area per block, not per pixel. We also had developed an algorithm to detect the hotspots in an area. So for this, we used the mimicked LSTM nighttime LST image from LSTM satellite, mimicked for the same area at 8:30 during a hot summer day. And we extracted the hotspots with a new algorithm that we have developed using AI. And we had a hotspot detection in industrial areas like the one that you see here. We also managed to detect roads, very busy roads in the area of interest. And something that is particularly interesting is that we saw that schools and schoolyards are actually detected as hotspots in the area. And you see the material abundance for these particular schools. And some images of these schools. And this, let me just go back and finish with the schools, is, we see it started from Paris with the Oasis project, but now we see it more and more in other European cities that they are renovating these schoolyards. They are changing these the schoolyards with they replace the cement with nature-based solutions, with green schoolyards, and this can be used as climate shelters as well. Okay, I close this note about schools and schoolyards. And here is another product that is the apparent thermal inertia, ATI, which you see on the left. When you see very light shades of blue, it's because you have big temperature swings. For this, we have used both daytime and nighttime LSTM data for the temperatures, and also the chime file in order to get the albedo. So this has to do with the albedo and the temperature. So you see, when you see light is big temperature swings or very dark surfaces, and when you see higher values with dark blue is where you have small day-night temperature swings. And if you zoom in, you realize that trees, lawns, and irrigated parks often show high ATI because evapotranspiration and shade keep their surfaces temperature swings small. And ATI is a proxy, so here high mostly signals plant cooling and moisture. And it is important to note that with this kind of map, it is safe to compare like with like roofs with roofs, parks with parks, before drawing conclusions about materials. So don't use this product on its own, but see it as part of a piece of a puzzle that would make you understand the whole picture. Also local climate zones. This is using CHIME and Sentinel-2 data for the same area, and we found 4 different zones, climate zones, that is compact with mid-rise buildings and low-rise buildings, and open with low-rise and large low-rise. So here you see the different classification for the local climate zones. And here I'm moving away from Athens and Sepolia because we don't have water there, but I'm moving to Helsinki. That is another city that is a case study, a pilot in HEATWISE, where you see the different water quality maps. So this is what it will look like. These are preliminary results at the moment. So the added information on water quality is about phytoplankton, group concentrations, and at the moment the relative team is developing more groups, more group concentrations, and you will also be able to see a time series for these concentrations, and this is important for water quality. And so this is it. I would like to, before thanking you for your presence here, I would like to ask you to respond to a very short survey, very quick survey that we have prepared. It's only 5 multiple choice questions, so it's extremely fast. It will take you 1 minute, but it will give us very valuable feedback regarding the products that you have seen, the project, but not only that, also to give us your priorities about the future urban products. And this is useful not only for the developing teams of the consortium, but it is also very useful for ESA and the future missions and the future products. So 2 ways of doing it. You can scan it with your mobile phone with a QR code, or you can use the link below to answer this using your desktop or your laptop. And yes, I think I just need to stress that your answers are anonymous. And with this, I'm going to stop sharing, and really thank you very much for your attention. And I hope that you took the time to answer the quick survey. Thanks so much.